You know, every single time you send a text, stream a video, or just browse the web on your phone, there's this unsung hero working tirelessly behind the scenes. It's really the engine of our entire wireless world, but most of us don't even think about it. That hero is the modem. So today, let's pull back the curtain and really get to know what this powerful little translator is and how it literally powers our connected lives.
Okay, so at the heart of all this is a fundamental language barrier. It's actually pretty simple. Our devices, our phones, our laptops, they think and they speak in a purely digital language. It's all just precise, clean strings of ones and zeros. But the airwaves, the physical medium that has to carry all that information, well, it only understands analog signals, like the smooth, continuous flow of radio waves. Two totally different languages. So that brings us to the big question, right? If our devices and the airwaves are speaking completely different languages, how on earth do they communicate? How do we translate these digital ideas into analog waves and then back again without losing anything in translation? Well, the answer is a really brilliant piece of technology that acts as this two-way bridge. Think of it like a sophisticated high-speed translator that perfectly connects these two different worlds. And that device, of course, is the modem.
You know, what's really cool is that the modem's name tells you exactly what it does. The word modem isn't just some random tech term. It's actually a mashup of its two main jobs, modulator and demodulator. Modem. It's all right there in the name. Okay, so let's start with the first half of its job, sending data out into the world. This is modulation. Your phone or computer generates digital data, those ones and zeros. The modem takes that data and uses it to modify or modulate a carrier wave. It cleverly imprints that digital information onto an analog signal, converts it to just the right radio frequency, and bam, sends it on its way through the antenna. And on the flip side, when your device is receiving data, the modem does the exact opposite. That's demodulation. The antenna picks up an incoming radio signal. The modem then gets right to work. It down-converts it, carefully strips away the analog carrier wave, and perfectly extracts the original digital ones and zeros so your device can understand it. So, we know what a modem does, but how does it actually pull off this technical magic? Let's take a look inside at the conceptual anatomy of a modem to see how the pieces fit together. All right, on the sending side, we have what's called the transmitter chain. The best way to think about this is like an assembly line where each station perfectly prepares the data for its tough journey through the airwaves. So on this assembly line, you've got these key blocks. The source and channel encoders, they compress the data and add extra bits to guard against errors. It's kind of like bubble wrapping your data for a rough trip. Then comes the modulator, which we just talked about, followed by the up converter, which shifts the signal up to the correct radio frequency. Every single step is absolutely crucial. And as you've probably guessed, on the receiving end, we find the mirror image of this whole process, the receiver chain. Its entire job is to meticulously undo everything the transmitter just did, to catch that signal and rebuild the original data with perfect accuracy. So an incoming signal is first down-converted from its radio frequency. Then the demodulator gets in there and extracts the digital information. And finally, the channel and source decoders check for any errors, fix them, unwrap the data, and hand it back to your device good as new. It's a really beautiful symmetric system. Okay, so that's the basic concept. But in our world of 4G and 5G, the modem has evolved so far beyond being a simple bridge. It's now an incredibly powerful processing core. I mean, it's practically a dedicated supercomputer sitting right inside your device. Seriously, today's modems are handling some immensely complex tasks. They're juggling advanced techniques like OFDM, which is a clever way to split data across many smaller signals, and MIMO, which uses multiple antennas to send and receive more data all at once. They are constantly analyzing the wireless channel, fixing distortion, and maintaining perfect timing. This whole suite of advanced functions, that's what we call the baseband processing unit. And this brings us to a really crucial distinction you need to know. There's the baseband, which is the digital world where all the heavy-duty processing, all the modem's brain work happens. And then there's the RF, or radio frequency part, which is the analog world that acts as the modem's voice and ears. The modem is the master of all that complex digital work happening in the baseband. Now, if you think that's cool, this concept gets taken to the next level in what's called software-defined radio, or SDR. In SDR, the modem isn't a fixed chip at all. Its functions are implemented entirely in software. This gives engineers incredible flexibility.
It lets researchers and developers prototype and test new communication systems, like for 6G, without having to build brand new hardware every time they have a new idea.
So after all this, why does the modem truly matter? Well, because it's not just another component. It is the absolute core of our communication systems. Its performance directly decides the speed, the quality, and the reliability of our entire wireless world. It's really the central nervous system for our data. It's responsible for efficient transmission, for correcting errors that just inevitably happen as signals travel through the air, for detecting incredibly faint signals from far away, and ultimately for weaving all of this together to give us the one thing we all want: reliable communication. And let me tell you, designing these modems is a massive engineering challenge. The designers are in this constant battle against noise, interference from other devices, signals bouncing off buildings and fading away, not to mention the simple physical limits of the hardware itself. This is exactly why modem technology is always evolving. And that is why understanding the modem is absolutely fundamental for any engineer or student working on the physical layer of communication. I mean, whether you're designing the next generation 5G systems or developing new digital signal processing algorithms, it all comes back to the core principles of the modem.
So let's boil it all down. If you remember three things, make it these. 1. A modem is that essential bridge between the digital and analog worlds, a modulator, demodulator. 2. It's the absolute heart of every modern wireless system. And 3. In systems like 4G and 5G, it's way more than a bridge. It's a super sophisticated baseband processing unit. Which leaves us with a final question to think about. As our world demands even faster speeds, instant connections, and linking billions of new devices for the Internet of Things, what do you think is the next great challenge for modem design? What new frontier will this unsung hero of communication have to conquer next?